Now, let's discuss about the line or intersection of two planes. You have two planes now, one in green color, another one is in blue. The intersection of the two planes actually is a straight line in red color. How to find this equation? To find the vector equation of the line, you need two information. Position vector that lie on the point, a vector that parallel to the line. So with these two information, then only you can write out the vector equation. Now, how to find a vector that parallel to the line in red color, the intersection line? We look at the normal to the plane. Now, the normal to the plane, and if you carry out the cross product of the two normal, you will get a vector that parallel to the line of intersection. This is something special. The line of intersection of the two planes actually is not easy to determine the direction. However, the product of the two normal we found is actually parallel to the line of intersection. So we will use this cross product of the two normal to determine a vector that parallel to the intersection line. Now look at this example. We want to find the vector equation of the line of intersection. You have two planes now. There are two methods. I show you the first method. So as you know, to find the vector equation, you need two information. First, we find a vector that parallel to the line of intersection. So we need the normal. From the equation, identify the normal. So, and then you carry out the cross product. When you carry out the cross product, you will produce a normal vector that parallel to the line of intersection. So you carry out the product, you have this result. So this is the vector that parallel to the line of intersection. So now you have the vector that parallel to the line. You need one more information, the position vector of a point. To find the point on the intersection line, you solve the simultaneous equation, equation of the plane. Then you will get an equation that involves x and y. So now, how to find that point? What we do is we choose a coordinate, let's say x equal to 0. You can choose any point, remember, not necessarily 0. You can use 1, 2, 3. So now, if x equal to 0, then in equation 3, you will get y equal to -2. So with the value of x and y, you can substitute in either equation 1 or 2 to find z. So this is the coordinate of the point. So with this, then you can write out the equation, the vector equation of the line. If you want to convert it to Cartesian equation, this is the answer. Look at the question. In vector equation, then this is your answer. So just now I say you can choose any point, not necessarily x equal to 0. Oh, see, if I choose, let's say I choose x equal to 1, then we see what is the result. So you take x equal to 1, you substitute back to equation 3, then you can you get y equal to -1, and then you substitute these two values into either equation 1 or 2, you have z. So for your calculation, this is the point that lies on the line, and your vector equation will be, now you do comparison between these two. So meaning that if we use different position vector, we will write out the equation in different with different point here. All you must know that there are so many position vector. Okay, there are infinite number of point here, depend on which point that you take. So the question now is, how do we know when we check your answer, this is the correct point, this is the correct equation? Because if I have 10 students, maybe 10, all of them may give me different position vector, so the answer can be slightly different here. So how to check whether this is the correct point, this point really lie on the intersection line? So what we did is actually you can substitute this position vector into the equation of the plane. It must fulfill both of the equation. If we fulfill both of this equation, then this is the correct one. Now I want to show you another method. This method don't need to use the vector parallel to the intersection line. Okay, so instead we solve the simultaneous equation to look for the relationship between x and y, and then x and z, and you can form a Cartesian equation. How to do it? First, we form an equation that relate x and y. So to do so, you need to eliminate z. So to eliminate z, from these two equations, you get an equation that relate x and y. So now you already have this part, okay, between x and y. So you need another one between x and z, or y and z. Let's say I want to eliminate z now. So look at equation 1 and 2 again. We multiply equation 1 with 2 first, and then look at equation 4 and 2. We can eliminate y. So this is the equation that relate x and z. So now you have x and y. Okay, you have x and y, and then x and z. So from these two, we can form an equation that relate x, y, and z. So from equation 3 and equation 5, we try to form an equation that relate x, y, z. So now you compare these two, which is in the form of Cartesian equation of a line. Okay, so this is the Cartesian equation of the line. and if you want the vector equation, just change it, convert it. So this is the answer. So there are two methods. Okay, so method 2, we don't use the vector that parallel to the line of intersection. But when you answer this type of question, you have to read the question carefully. If the question asks you to find a vector that parallel to the line of intersection, hence use it to find the equation, you must use that method. Okay, don't use method 2. So read the question carefully.